There is another method to solve linear systems, the elimination method. Here are the steps used in the elimination method. We obtain opposite coefficients of x or y by multiplying the equations by suitable constants. We add these new equations and solve for the remaining variable y or x. We repeat steps 1 and 2 for the other variable y or x. Instead of repeating steps 1 and 2 for the other variable, we could substitute the result for x or y into one of the equations and solve for y or x. Let's illustrate this with the examples on page 32. Question 1. Solve 2x minus 4y is 5 and 5x plus 3y is 6. Notice that this is an example that we solved using the substitution method, and it was quite complicated because fractions were involved. Here we will use the elimination method. To eliminate x, we want to multiply the equations by a suitable constant to obtain opposite coefficients of x. We want to multiply the first equation and the second equation by certain numbers, such that the coefficient of x in the first equation is, let's say, 6, and in the second equation, negative 6, the opposite of 6. How can we always do this? We can always multiply the coefficients of the first equation by the coefficient of the second equation. Here we can multiply the first equation by 5 and the second equation by negative 2. We multiply the first equation by 5. Don't forget to multiply both sides of the equation by 5. And we multiply the second equation by negative 2. We FOIL out and simplify. Now we add up these equations and solve for y. Notice what happens when we add them up. 10x plus negative 10x is 0. Negative 20y plus negative 6y is negative 26y. And 25 plus negative 12 is 13. We have eliminated x. We can solve this equation now by dividing both sides by negative 26. We simplify and we find that y is negative 1/2. To eliminate y, we want to multiply the equations by a suitable constant to obtain opposite coefficients of y. Notice that we could substitute the value of y into an equation and solve for x, but that would involve fractions. So here are the original equations. We want to obtain opposite coefficients of y, so we can multiply the first equation by 3 and the second equation by 4. First equation by 3 and the second equation by 4. We FOIL out and simplify, and we add up these equations and solve for x. 6x plus 20x is 26x. Negative 12y plus 12y is 0. 15 plus 25 is 39. We solve for x by dividing both sides by 26 and simplifying. Remember that the solution to a system of equations is a couple, so the answer in this case is 3/2, negative 1/2. Question 2. Solve the system 4x minus 3y is 7 and 6x minus 2y is 3. We use the elimination method. To eliminate x, we want to multiply the equations by a suitable constant to obtain opposite coefficients of x. We could multiply the first equation by 6 and the second equation by negative 4. But we can do better because the least common multiple of 4 and 6 is 12. It is possible to turn the coefficient of x into a 12. We multiply the first equation by 3 and the second equation by negative 2. First equation by 3, second equation by negative 2. We FOIL out and simplify. Now we add up these equations and solve for y. 12x plus negative 12x is 0. Negative 9y plus 4y is negative 5y. 21 plus negative 6 is 15. We solve for y by dividing both sides by negative 5 and simplifying. To eliminate y, we want to multiply the equations by a suitable constant to obtain opposite coefficients of y. Here is the original system. We can get opposite coefficients of y by multiplying the first equation by 2 and the second equation by negative 3. The first equation by 2, second equation by negative 3. We FOIL out and simplify. Next we add these equations and solve for x. 8x plus negative 18x is negative 10x. Negative 6y plus 6y is 0. 14 plus negative 9 is 5. We solve for x by dividing both sides by negative 10 and simplify. Since the answer to the system is a couple, we get that our answer is the couple negative 1/2, negative 3.